Um, we are going to look at absolute values. Absolute values. Now we are going to define absolute values as if you look, we can look into the book. If you can look on page we are on page 23. On page 23. Are you there? Page 23. Are you there?
Yes.
Okay. Now, it defines absolute value as if you have, how do I put it? Let me put this. Anytime you have an absolute value of A, when you have an absolute value of A, we did it the first semester. Anytime you have, it will be equals to a positive A if A is greater than or equal to 0, and it can also be to a negative A if A less than 0. So we are
So
going
you're
to,
breaking.
okay, can you hear me clearly?
Yes, now we can hear you clearly.
Okay, good. So if we have, let's say, modulos, if I say solve for x, if I say solve for x, solve for x, then I have, let's say, modulos 5 minus x equals to, let's say, 7. There will be two ways. You can have, if you remove, once you remove the modulos, it can be, the modulos can be positive. It will be 5 minus x equals to 7, positive. Then you can have 5 minus x equals to negative 7. So we can say x here, x can be equals to minus 2, and here x can be equals to 12. Please, I hope you remember this.
Yes, sir.
Okay, good. Now, but for this semester, we are going to look more at inequalities. You understand me? So, when you have this, your solution will now become minus 2 to 12. It will be a set. It will not be an interval. Have you seen that? It will be a set of solutions. 2 to minus 2 to 12. Or the set minus 2 and minus 12. So let us do another one. In the same way, if we have absolute value x minus 1 divided by 2x plus 3 divided by 2x plus 3. Then you have it says equals to 4. Equals to 4. We are going to have two different solutions. Modulus x, I'm sorry, there will be no modulus. When you remove the modulus, it becomes x minus 1 all over 2x plus 3 equals to 4. Then x minus 1 all over 2x plus 3 equals to minus 4. Then you solve for x in both. Then you write the answer in a bracket in a set form. But in this chapter, what you must know is how to write. What you must know is how to write your how to how do I call it? Solve absolute values when it's in the form of an inequality. How to solve absolute values when it is in an inequality. So please, when you look at page 24, there are some properties of absolute value that you must take note of. It's on page 24. There are some properties of absolute values that you must take note of. And the most striking one is if you have modulus of x greater than a. You have to know that it can be two ways. X can be greater than a, and x can be greater than minus a. Does it make sense to you? Does it make sense to you? Hello?
Sir,
Yes. Hello?
yes, it does make sense. You can continue, sir.
Okay, good. So whenever you have this, it means that this your x is going to be between minus a and a. Please, I would like to show you this on the number line. Have you seen that? Look, on the number line, let us say if here is minus A. Here is going to be A. Have you seen that? So here I'm saying that X is greater than minus A. It will go like this. Can you see that? Then at the same time, I said X is greater than A, which is going to be let me replace. Okay. Please, in order not to confuse you, simply put, when you have modulus of X greater than A, it simply means that X is between negative A and positive A. A will always be between negative A and positive A. So I would like us to take an example. An example is if we have an example is if we have this. Let me just take one example here. Okay. If you are asked to solve absolute value of X minus 2 less than or equal to 3, absolute value of X minus 2 less than or equal to 3. So we are going to have X minus 2 less than or equal to 3, then X minus 2 greater, still less than or equal to minus 3. Does this make sense?
Yes.
Yes, it makes sense. Yeah.
Are you sure this thing makes sense to you? Check it properly.
It's making sense. It's making sense.
Definition variable. I said if you have modulus of A greater than X, look at the definition very well. If I say modulus of A, if I say modulus of X greater than A, if I say modulus of X greater than A, it means that X is greater than minus A and X is less than A. Can you see that? So now let us bring the same thing here. If I say modulus of X minus 2 less than or equal to 3, it means that X minus 2 is greater than or equal to minus 3 and less than or equal to 3. Can we see that? So rather, the solution should be like this: X minus 2 greater than or equal to minus 3, and x minus 2 less than or equal to 3. Have you seen the difference? Can you see the difference now? Or can you see where that this one is wrong? Can you see that? Please confirm whether you can see that.
No, we can't.
Look at this one. Look at the sign. It is less than. Less than. Look at this one. Here, this one is greater than. Can you see it?
Yes.
Because of the rule of this rule. Can you see that? X minus 2 must be greater than or equal to minus 3. At the same time, x minus 2 must be less than or equal to 3. Can you see that?
Yes.
It makes sense to you now.
Yes.
Okay. I'm the rest. Any questions?
No.
Okay, good. So we can say that x is greater than or equal to minus 1, and x is less than or equal to 5. But please, you are not finished with the answer. Is that clear? So when you come, you have to draw a number line like this. Have you seen that? Please, it is not a design. You are just using it to find your answer. So don't go and waste the time, please. So you have minus 1 here. Have you seen that? Then you have 5 here. Now, the first answer says that x is greater than or equal to minus 1. So you shade. Then your graph goes like this. The second one says that x is less than or equal to 5. So your graph goes like this. Then you find the intersection of the two. Can you see that? It intersects here.
Yes.
Have you seen that? So your answer will be
Yes.
x greater than or equal to minus 1 less than or equal to 5. Or if you write it in an interval form, it will be minus 1 to 5. Does it make sense?
No, I don't understand this one.
Yes. What don't you understand?
Why the interval is not closed?
Uh, okay. Thank you very much. Thank you very much. It's a mistake on my side. Because it's greater
Okay.
than or equal to the interval is closed. I'm very sorry. I'm very sorry. Yeah, Rainy, your hand is up, Rainy.
Also, I wanted to ask the same question.
Okay. Okay, then it's fine. Thank you. Okay, so let's look at another example. If we have for instance, let us do it's the same thing, eh? So let us do 1 or 2 examples, then we do midpoint interval, then we close. Now let us say they give you 2x plus 1 less than 1 over 4. If you are given 2x, absolute value of 2x plus 1 less than 1 over 4. It simply means that this 2x plus 1, this 2x plus 1 is greater than minus 1 over 4 and less than 1 over 4. So now we have two inequalities. 2x plus 1 greater than minus 1 over 4 and 2x plus 1 less than 1 over 4. So if we simplify, we see that here x will be greater than let's see our answer, 3 over 8. X will be greater than 3 over 8. And here x will be less than 5. Sorry, here x will be greater than minus 3 over 8. Sorry, and here x will be less than 5 over 8. So on our number line, if here is 0, you are going to have minus 3 over 8. And here you are going to have 5 over 8. 3 over 8 greater than will go like this. Arrow. 5 over 8 less than will go like this. Arrow. Then our interval will be here. So here x will be greater than minus 3 over 8 and less than 5 over 8. Then in an interval form, you can get minus 5 over 8. Sorry, minus 3 over 8. I'm so sorry. To 5 over 8. Now let us do one last example. Let us do Rainy. Yeah, your hand is up.
Okay, so to get like negative 3 over 8, right? Isn't it, you say minus 1 both sides?
Yeah, I took
I'm
1 here.
pointing.
Oh, this answer is wrong.
Yeah,
It's 3 over
even
4.
the other one.
Oh, sorry. Let's do it again. We have modulus, absolute value of x plus 1 greater than is an absolute value. greater than 3/4, greater than 1/4. So from our concept, we have 2x plus 1 greater than minus 3/4 less than 3. Sorry. It's 1/4. Less than 1/4. 1/4. So to solve, we are going to have 2x plus 1 greater than minus 1/4 and 2x plus 1 less than 1/4. So if we simplify this, x will be greater than minus 5/8. Am I correct, Rennie?
Yes, sir, you're correct.
Yes.
Okay. Then the second one, x will be less than minus 3/8. Good. So we come to our number line. Please, minus 5/8 in decimals is how much? Minus 5/8 in decimals is how much? Can somebody punch for
Negative
me?
0.625.
Minus
Negative
0.62.
0.625.
62. Okay. Then
Make it 6.3,
minus
sir.
3/8
Make it
is 0, what?
make it
0.65.
No, I just want the I just want to check something. I want so I just want an approximate value. Is 0, what?
0.625.
625. 625. Okay. Then x. What about negative 3/8?
0.375.
0,
375.
375.
375. Okay. 375. Okay. So on our number line, let me just use this one to draw our number line. If we draw our number line like this, a minute. We are going to have 2 points here. So our first one, so that means that negative 3/8 will come first. Have you seen that? Negative 3/8 will be here. Then negative 5/8 will be here. So it says that greater than negative 5/8, it will go like this. Then it says that and it's a whole. Then it says that less than negative 3 over 8. So it will come here like this. So our intersection is going to be here. Our intersection is going to be here. So we are going to have negative 5 over 8 greater than x less than negative 3 over 8. Then in an interval form, we can write it parenthesis minus 5 over 8, comma, minus 3 over 8. Please, any questions there?
No, we got it.
It's clear there. Okay.
Yes.
Then let us look at question 10 and 11 on activity 1,5, which involves what do you call it? It involves no. I would like us to look at one last question. Absolute value of x plus 1. Let us look at this one. Absolute value of x plus 1 greater than 2. Let us look at these examples. Absolute value of x plus 1 greater than 2. Let's look at this example. Now, this example, you are going to see that it will go like this. This x plus 1 will be greater than negative 2 and less than 2. So we are going to have x plus 1 greater than negative 2, x will be greater than negative 3. Then x plus 1 less than 2 and x will be less than 3.
It will be less than 1.
Yes. Come again.
It will be less than 1.
Hello? Dear,
Yes.
Yes.
I want to ask a question.
Yes.
Okay.
Okay, when solving these inequalities that involves absolute values, you see,
Yes.
we're dealing with different. We're dealing with different signs.
Yes.
It can be greater, it can be less. Is it true?
Greater than it can be less. Yeah.
So I want to know the golden rule. So the golden rule, we are applying the one which lies between negative 8, where x lies between negative 8 and
And
8
minus.
for all the inequality signs, like either greater or less.
No.
Mm.
No. Let us look at the. It's a very good question. Thank you very much. Let us look at the rules on page. Where is it? Where are those rules? Please, let me try and get you the rules It is on page 2. Okay. Can we go to if all of you have your books, can we go to page 24? Yes, your hand is up. Your hand is up.
It was a mistake, sir. Sorry.
Okay, good. So please, you have to know that the sign can be greater than and the sign can be less than. And the way we handle it is not the same. Please, it's a very good question that Sabelo asks. Now, if modulus of x is less than a, then this x can be greater than minus a, and this x can be less than a. Does that one make sense to you, Sabelo? Sabelo, does that one make sense to you?
Yes, it does. It makes sense.
Okay, good. So our next one is when if modulus of a is greater than a. In that sense, this x will be greater than the positive, and this x will be less than the negative.
Yes, it makes sense. I can see it's just opposite inverses. It's an opposite of
When there's
the
a
original
negative,
one.
yeah, you change the sign. Can you see that? When there's a negative, the sign changes. If you will forget, look at the original one. Can you see that? So if there is a negative, see that here there's a negative, so this sign will change to greater than. Can you see that? Can we see that?
Yes,
Please, the rest, it's important that you confirm whether you understand this.
I
Yes, we
understand
do.
very clearly.
Okay, good. Really, do you understand this?
Hmm? We do.
You do?
Yes, sir.
Okay, good. So now, if I have this question, let us say absolute value of x plus 1. Absolute value of x plus 1 greater than 2. You are going to have x plus 1 greater than 2 and x plus 1 less than minus 2. When it's a minus, the sign will change. Can you see that? So x
Yes.
will be greater than 3 and x
Hmm.
will be less than minus 3. So on our graph, it will be like this.
Sir, why did you say x will be greater than 3? Isn't it supposed to be 2 minus 1, not 2 plus 1?
The question says absolute value of x plus 1 greater than 2. So,
Yeah.
oh, it's 3. So the first one is x plus 1 greater than 2. Oh, the answer will be, it's supposed to be 1. Oh, okay, sorry. I'm sorry. I'm so sorry. Thank you very much. So we have, so that means here will be 1, and here will be minus 3. Please let me just draw the graph here. So we are going to have minus 3 and we have 1. So it says that greater than 1. So it will go like this. Hold. And less than minus 3. It will go like this. So it means that here, if you want to look at it on the graph in the interval, it will be negative infinity to negative 3
Yes.
union 1 to positive infinity.
Infinite.
Does it make sense?
Yes.
Okay, good. So please take note of this thing very carefully. It's very important, because if you make a mistake there, it will affect everything that you are going to do. Is that clear? If you make a mistake there, it's going to affect everything you are going to do. Now let us look at one last one. Now we have let us look at the one linear, then we look at one what do you call it? Let us look at one linear, then the other one involving a quadratic equation. Now if I give you this, absolute value of 7 minus 3x greater than or equal to 12. So we are going to have 7 minus 3x greater than or equal to 12, and 7 minus 3x less than or equal to 12. So we are going to solve these two. We are going to get minus 3x greater than or equal to 19. Then remember that if you divide through by a negative, the sign will change. Have you seen that? So x will be greater than or equals to, I'm sorry. So the sign will change. So x will be less than or equal to minus 19.
19.
Yes, this 7 will come here. Oh, it's supposed to be, it's subtraction, so it's supposed to be 5. Sorry. So we are going to have x less than or equal to minus 5 over 3. Then here we have minus 3x less than or equal to
Negative 90.
here was negative 1. No? So it's going to be minus 3x less than or equal to minus 19.
Yeah.
Can we see that? So when we change the sign, x
Yeah.
will be greater than 19 over 3. Then on the number line,
Greater than or equals to negative.
yeah, so greater than or equal to, yeah. So we are going to have minus 5 over 3, then 19 over 3. Here we'll go here. I'm saying that greater than or equal to. Then this one will come here, less than. So it will be from negative infinity to five minus 5 over 3. Then union 19 over 3 to positive
Infinity.
infinity. Then you close it like that. So please, you have to be, you see, because you are writing a multiple choice, the slightest mistake, you get the whole thing wrong. The slightest mistake, you get the whole thing wrong. Good. Now, let us look at the ones involving, yes, your hand is up.
Say, can you
Yes,
please start? Can you please start over? I don't understand.
I should start over. Okay, good. We have absolute value of 7 minus 3x greater than or equal to 12. So we are going to have two solutions. The first one will be absolute value 7. Sorry, when we remove the absolute value, we are going to have 7 minus 3x greater than or equal to 12. Then the next one we are going to have 7 minus 3x less than or equal to 12, negative 12. Positive and negative. It is one clear. Is this one understood before we go on?
Yeah, I understand, sir.
Okay, good. So here, if I simplify this, I can get minus 3x greater than or equal to 5. Then when it's I divide by a negative, the sign changes. So x will be less than or equal to minus
Negative
5
5
over
over
3.
3.
Good. Then here I will get minus 3x less than or equal to minus
Negative.
19. Can you see that?
Yes, sir.
So x will be greater than or equal to
Negative
19.
over 3.
Good.
19 or positive 19 over 3.
Positive 19 over 3. So when
Yes.
you draw your graph like this, you are going to have minus
3 over
5
5.
over 3 here. Have you seen that?
Yes.
Then 19 over 3. But here 19 over 3 is greater than or equal to, so it will go here like this. Can you see that?
Yes.
Then this one is less than, so it will go here like this. You see?
Yes.
So if you are writing it in an interval form, it will be negative infinity to minus
Minus
5
over.
over 3. Have you seen that?
Yes.
This one will be a parenthesis, but this one will be a closed bracket. Union closed bracket 19 over 3 to positive infinity.
So can you please explain the arrows of the number line?
When it's less than, it goes left. If it's greater than, it goes right, depending on your answers.
Oh, thanks.
Is that clear? If it's whenever x is less than, it goes to the left. Whenever x is greater than, it goes to the right. And when it's greater than or equal to, you shade the inside.
Yeah.
Yes, I understand.
Yeah. Any questions again? Please,
No,
any
I
questions
understand.
again? Okay, it's clear. Okay, good. Now let us look at how do I put it? Let us look at one example involving quadratics. It says that x squared minus 4 greater than 0. It says that x squared minus 4 greater than 0. So here you're going to have two solutions. The first one will be x squared minus 4 greater than 0. And we are going to have x squared
Minus 4
minus 4
less than 0.
less than 0. So here you are going to have x difference of two squares. X plus 2
X plus 2.
x
X
minus 2.
minus 2.
Have you seen that? X
Yes.
minus 2 greater than 0. Then here you are going to have x plus 2 x minus 2 less than 0. Now here, if you draw the number line, it will be like this. Have you seen that? So greater than will be here and here. So here it will be, you can also use the table method anyway. You can have x less than 2 and x greater than 2. Then here, if you draw the number line, it's going to be like this. Then we have the graph like this. And it will be in the middle. Can you see that? It will be in the middle. And it will be x between -2 and 2. So now, on the number line, yeah. Any questions?
No.
Please, it's very imperative for you to see how you get the final solution. The final solution, you have your graph like this. Have you seen? And you see that this thing, it does not intersect each other. Can you see that? So you are going to have 3 solutions. You see that? Because when you draw your number line like this, you are going to see that if here is
0.
let us say if here is 0, have you seen
Yes.
that? Here is
Yes.
-2 and here is 2. Now this one, it will go like this and like this. Have you seen that? And this one will be in the middle. In the middle here. You see that? So that means that there is no intersection. Can you see that there is no intersection?
Yes, there is no intersection.
So we have this one, you write your solution. Negative infinity to
-2.
sorry, negative here to -2. Then you come
Union
union 2
to positive
to
infinity.
positive infinity union -2 to what? 2 for this one. Can we see that? Yes, your hand is up. Your hand is up.
Sir, can you start afresh? I don't understand.
Please, if you don't understand, please prompt me where you don't understand. Don't wait for me to finish the whole thing, please. We have x squared minus 4 greater than 0. Let me see that. It's an absolute value. So we can have x squared. Yes. Your hand is up. Your hand is up. Can I go on? Okay. So we have x squared minus 4 greater than 0. And we can have x squared minus 4 less than 0. Is this understood? Before we go. Please, is this understood before we go on?
Yes, sir.
Okay. We are going to have x minus 2 x plus 2 greater than 0. Then here we have x minus 2 x plus 2 less than 0. So here, if we can draw our number line, remember that last time we saw that we can also use the table method. We are going to have minus 2 and 2. Then if you draw your graph, it will be here and here. Have you seen that? So it will be x less than minus 2 and x greater than 2. Is this understood? Please, is this understood? The answer.
Yes, sir.
Yes, sir.
Okay, great. So here, if we draw our graph, it will be like this. It will be from minus 2 to 2. And because it's less than, it will be in the middle here. You see that? So our answer here will be minus 2x, sorry, x between minus 2 and 2. So if you can check on the number line, these two things, it cannot intersect. Can you see that? Can we see that clearly?
Yes.
So we must combine this answer. This one is this one. It will be from negative infinity to minus 2 union. The second one will be from minus 2 to 2. Then union, this one will go from 2 to positive infinity. Then we have our answer. Does it make sense?
Yes.
Okay, good. Please, any questions again? Please, any questions again?
No, we don't have questions.
Okay. Now, let us look at so please, that is all. Once you understand this, you can take your time and you can always get your answer. Exactly. Please don't do anything easily. Take your time, analyze the thing. And you remember that in the first class I told you that never cross multiply. If you cross multiply, you are doing a lazy way. Exactly. Never. Okay, good. Now, please, the next is that one is not difficult. Is how to find the turning point. Sorry, I said turning point. How to find your midpoint and how to find your distance. That one is not difficult. It's in the book. So please look at it before you answer. Midpoint, you just add the 2 points and divide by 2. I will say, what do you call it? Distance, just subtract the 2. But remember that distance is always positive. Exactly. So you just subtract the 2 and find the absolute value. You give the positive number. Exactly.
Yes.
So that is what you must look at. So please, you know that your exam has your classes have already started. I will say, and I advise you to write early. Don't wait last minute. Exactly. Where the system normally becomes jam. And if you have any issues, please, if you email me, is useless. You can copy me the email, but write both to email the question. Exactly. So, in the absence of no question, I would like to bring the class to an end so that you can go and prepare for your semester, for your class test. Unless there are questions. Are there any questions? Please? Are there any questions, please?
No, sir.
No.
Okay.
No,
Okay, if
sir.
there are no questions, then let's bring the class to an end and prepare for the test. So, good luck with the test.
Thank you very
Bye
much,
bye.
sir.
Bye bye. Have a nice day.